Good morning all of you. In this video we are going to learn about chemical equation. It is the same chapter, language of chemistry. This is a new topic in that chapter. To understand what is chemical equation, it is the shorthand form of, it is a statement which actually describes a chemical reaction in terms of symbols and formula. So when I write a chemical reaction using symbols and formula representing a chemical change, the shorthand form of writing the chemical change is the chemical equation. Alright, now let's take an example of a chemical equation. I am talking about a reaction between ammonia and water. When ammonia and water reacts together, it forms ammonium hydroxide. In this chemical reaction, ammonia and water are written on the left hand side. They are participating in the chemical change, so we will call them reactants. And ammonium hydroxide, which is produced at the end of the reaction, is known as products. The direction of the reaction is represented by using an arrow. NH3 is the chemical formula for ammonia, H2O is water, and NH4OH is the chemical formula for ammonium hydroxide. Okay, so we've got two reactants which are participating and forming one new product, which is ammonium hydroxide. Whenever you write a chemical equation, always try to mention the state of the substance. For example, ammonia is present in gaseous state, water is present in liquid state, and ammonium hydroxide, because it remains dissolved in the solution it is prepared, we are going to represent it by writing AQ in brackets. AQ basically means an aqueous solution. Okay, it is a solution which is prepared in water. In ammonium hydroxide, the ions present are ammonium ion and hydroxide ion. Once ammonium hydroxide is prepared, ammonium and hydroxide ion remain dissolved in the solution. What kind of information do you get from a chemical equation? The first information that you get is the chemical nature of the reactants and the products. For example, I have mentioned the states of the reactant and the product in gaseous state or liquid state. So the nature of the substance is known. You also find out what are the radicals and elements present in a chemical equation. For example, we saw that reactants consist of the compounds ammonia and water. The product formed is ammonium hydroxide. I told a little while ago that ammonium hydroxide remains dissolved in water in the form of ammonium ion and hydroxide ion. So by looking at a chemical equation, you can find out what are the elements present or what are the radicals present. The direction of a chemical reaction is represented in an equation with the help of an arrow. There are two kinds of arrow. You have an arrow with which is written in both the directions, which is called a reversible, and the one which we have in this example is an irreversible arrow. So these are the following information that you can understand or get by looking at a chemical equation. Now let us find out what are the limitations of a chemical equation. Although we get different number of informations about a chemical reaction, there are some limitations also. Okay, what does it not provide? When you look at a chemical equation like the one that we have mentioned over here, firstly, we do not understand or we do not know the speed of the reaction. Is the reaction a fast reaction or does it take place in 2-3 days? Is it a slow reaction? So the speed of the reaction is not, the information about the speed of the reaction is not provided in a chemical equation. The second thing which is not provided in a chemical equation is how concentrated or how dilute are the reactants or the products. Alright, so you might have used concentrated solution of acid in some example. How concentrated is it? What is the concentration in numerical value? It is not given in a chemical equation. Thirdly, whether there is a change in color. Alright, whether there is a change in color is not mentioned in a chemical equation. Remember that chemical equation comprises of symbols and formula of different elements and compounds. Alright, that information is not given in a chemical equation. Lastly, whether the equation has completed or not, that is also not provided. Okay, so there are 4 things which are not provided, which act as the limitation of chemical equation. You do not find out the speed of the reaction, the concentration of the reactant and the products used, whether the reaction has undergone completion or not, and if there has been a change in color or not. Okay, so these are the following limitations of a chemical equation. We are going to try and understand why do we have to balance any chemical equation. Let's take an example of magnesium, which is a metal, being added to a dilute solution of hydrochloric acid. Notice that I have mentioned that the solution is a dilute solution in brackets beside HCl. Okay. The compounds formed are magnesium chloride and hydrogen gas. Let's look at the reactants. The elements present in the reactants are represented by their symbols. So you can see the symbol Mg. Mg is for the element magnesium. If you want to know how many atoms of the elements are present, you need to look at the base of the symbol. Is there any number written or not? If there is no number written, we consider the number of atoms of that element to be 1. So there is 1 atom of magnesium. The second element is hydrogen. We see no number at the bottom of hydrogen, so there is 1 atom of hydrogen. The next element is chlorine. There is 1 atom of chlorine in the reactant. Let's see in the products if we have the same number of atoms or not, or the same elements or not. If you notice, we have magnesium, chlorine and hydrogen. Magnesium, how many atoms? 1. Chlorine, at the base of Cl there is 2, so there are 2 atoms of chlorine. Hydrogen, at the base of hydrogen there is the number 2, so there are 2 atoms of hydrogen. If you notice, the number of atoms of magnesium in the reactant is the same as number of atoms of magnesium in the product. So magnesium atoms on both sides of the reaction are accounted for. However, number of hydrogen and chlorine atoms are not same. They are different. So we are going to try and make sure that the number of atoms are same on both the sides. Why? Because every chemical equation abides by or follows the law of conservation of mass. What is law of conservation of mass? According to this law, mass can neither be created nor destroyed in a chemical reaction. It means that the total mass of the reactants is always equal to total mass of the products in a chemical equation. Mass of the reactant and the product will only be same if the number of atoms in the reactant are same as number of atoms in the product. Okay, so whenever you are balancing a chemical equation, you are trying to make sure that the number of atom of each element present on both the sides of reactant and product are equal. Why are you doing this? Because every chemical reaction follows the law of conservation of mass. That is why we need to balance a chemical equation to make sure that when you are writing a chemical equation, the number of atoms of each element is same on both the sides. Now the method that we use to balance the reactants and the product is called hit and trial method. In this hit and trial method, we are going to write down the name of the elements or the symbol of the elements and atoms, number of atoms of each element on both the sides, on the reactant side and also on the product side. So let's quickly go ahead and write it. So we have magnesium 1 atom, hydrogen 1 atom and chlorine 1 atom in the reactants. On the product side, what all do we have? We have magnesium, hydrogen and chlorine. How many atoms of magnesium? The number of magnesium atoms is actually the same. Okay, so there is 1 atom of magnesium. If you look at the number of chlorine atoms, how many are there? At the bottom of Cl, there is the number 2. So there are 2 atoms of chlorine, and at the bottom of hydrogen, there is the number 2. So there are 2 atoms of hydrogen. Now, we are going to balance the chemical equations by writing numbers in front of the compound or element in the reaction. So the boxes that I am drawing here, this is where I am going to write numbers to make sure that the number of atoms is same on both the sides. Alright, these numbers are what are known as the stoichiometric coefficients. These numbers are known as stoichiometric coefficients. So let's try to balance this equation. What do we see? Magnesium is balanced on both sides, so I'm not going to disturb that now, but I am going to balance hydrogen first. What do we see? There are 2 atoms of hydrogen on the right hand side, but on the left there is only 1 atom. So what number can I write in front of HCl which will make the number of atoms of hydrogen same on both the sides? So the simple number what I write in front of HCl will be multiplied by 1, which is written at the base of HCl. Okay, so if I write the number 2, that means I will multiply this 2 with the number 1 at the base of HCl, and that brings my number of hydrogen atoms to 2. You will only multiply these numbers after writing the number in the chemical equation, not before that. Because you have written 2 in front of HCl, that 2 is also for chlorine atoms. Because of writing 2 in front of HCl, you have also changed the number of chlorine atoms. Before, you had 1 chlorine atom. After writing 2, the number of chlorine atom becomes 1 into 2, which is 2 now. Okay. So just by simply writing 2 in front of HCl, you will notice that number of hydrogen and chlorine in the products has become equal to the number of hydrogen and chlorine in the reactants. Right? So this is now a balanced equation. You will notice if I have not written any number in front of the element or the compound formula, that means it's not 0, it is 1. So my final equation becomes Mg plus 2HCl forms MgCl2 plus H2. How will I read this equation? This equation reads 1 atom of magnesium combines with 2 molecules of hydrogen chloride to form 1 molecule of magnesium chloride and 1 molecule of hydrogen gas. So this is my complete balanced equation. Thank you all of you. In the next video, we are going to look at another example of balancing chemical equation.